order for the flow, the web to have that flow, it has to come from somewhere, right? So I'm going to construct the rest of the Q. Okay, so it will come from here. The other one will come from here. Can you see the pattern? How I construct the shear flow, right? And then at the bottom, it will split. And then it will split. So again, you have the dots are all your what? Terminus, yes or no? Right? Okay, then now the first, so I'm going to calculate the Q at point A. Okay, so Q at point A. So I'll draw my transformation first. Right. This is Y, and this is Z. Okay, so we're going to look at the Q at point A. Okay, so we are going to find Q about the Z-axis, right, at point A, and it's equal to the width, depth, Y bar. Okay, so this is our width, right, and this will be our depth. The width and depth is relative to your Vy, by the way. Okay, parallel to your Vy is your or if you want to look at this, because is the formula is the shear is equal to Vy over what Izz. Okay, so what is of interest over here is our ZZ direction. Okay, so if this is our centroid, right? So this is our centroid, right? So this is still our what? ZZ. So that's our width and that's our depth. Right? So at point A, the width, right? So we know that the thickness is what? The thickness is 1/8. The width is 1/8. However, the depth is 0. The Y bar is equal to 0. So it's equal to 0. Right? So from here, we know that the shear stress at point A will be equal to what? 0. Okay? Then we are going to find the QZ at point B. All right, so point B is up to here. Right? So I'm going to shade yellow. It's up to here. Right? So that is our point B. Right? So if we were to look at our point B. Now, but before I go anywhere, right? I do apologize. So this is at point A is also a wide flange analysis, right? At point B is still a wide flange also. Okay. So if you can see the solution manual, okay, which I already posted online, you can see whether is my answer right or wrong, or my working right or wrong, okay, analysis. But the more important thing is to find the first moment of area. So QZ at point B, right? So the width is still 1/8. Now the depth is 1.25, right? And then it's 1.25 divided by 2, approximately, because we don't know what is this gap, right? I'm going to assume that it's very small. That's why I assume it to be 1.25. Okay. So QZ. Right. So this is equal to 1.25. That's by 1.25 divided by 2 times by 1/8 is equal to 0.09766 inch to cube. Okay. So if you check, the answer is also correct. So now we look at point C, right? Point C, so all these are wide flange analysis. Right? So we are going to find QZ at point C. So now we have to include this area down here. Right? I'm shading in blue. I don't think you can see, my apologies. Now we have to consider this with the highlighted yellow. Okay. So this will be QZ at point B, right? Plus. So now the width is so we know that up to the center is, so now I have to find this distance over here, right? So 1.25 minus, so this distance, the width is equal to 1.25 minus by 1/8 minus by 1 over the 16, right? Because is half, right? Or yeah, yep. Okay, so that's the width, and then the depth is 1/8, and then the y bar is 1.25 minus by 1 over 16, or 1/8 multiplied by half. Okay, so this is equal to 0.09766 plus, so one side of the wall is 1/8, half of the other side is 1 over 16. Okay, so 1.25 minus by this, so it's 1.0625. Let me do it again. So 1/8 minus 1 over 16. No, it's 1/8 plus 1 over 16. Minus 1.25, 1.6. Okay, so multiply by 1/8. So 1.25 minus 1 over 16 is equal to 1.1875. Let me do it again. 1.25 minus 1 over 8 times 1 over 2. 1.1875, 18. 1.25 minus 1 over 8 minus 1 over 16. Okay, 1.0625 times by 1 over 8 times by 1.1875. So it's equal to 0.09766 plus by 0.1577. Okay, so 0.09766 plus by 0.1577. So I got 0.25536. Okay, 0.25536 inches to the power of 3. Okay, if you look at the working from the textbook, yeah, our working is quite similar. Okay, but I break it down further. Okay, so that's point C. So to find point D, right, to find point D is this entire Eugene, wrong color, man, mate. We have now to consider the two blues, the two yellows, which I'm highlighting now, right? And then you have to consider this area down here, and then you have to consider this part down here. You have to be really careful with this. Okay, if you're not careful, you will miss out on the area. Okay, you will you don't want to miss out on the area. Okay, so let's do this. So at point D, right, at point D, again it is a wide flange analysis, right? So the QZ at point D is equal to twice the QZ at point C plus by the small orange that I circle, right? So that is equal to the width is 1/8. The depth is also 1/8. Then is 1.25. And 1.25 minus by 1/8 and half. Close bracket. So this is equal to twice 0.25536 plus by 1/8 with depth, and this one is 1.25 minus 1/8 minus 1/8 times half. 1.25 minus is equal to 1.1875, right? So this is equal to 2 times 0.25536 is equal to 0.51072 plus 25536 times 2, 1.1875 times by 1/8 times 1/8 is equal to 0.018555. So this will be equal to 0.51072 plus by 0.018555. So it's equal to 0.052928. Okay. So finally, we want to find, I'll copy and paste here. We're going to find the E, okay, which is also a wide flange analysis. Okay. Oi. So QZ at now point E. So it's going to be QZ at point D, right? So QZ at point D plus by this. Okay. So we know the width is 1/8. The depth is 1.25 minus 1/8. Right? Then multiply by 1.25 minus 1/8 multiplied by half. Okay. So this will be equal to 0.52928 plus by 1.25 minus 1/8 squared times by 0.5 times by 1/8 is equal to 79.102 times 10 to the power minus 3. So this is equal to 0.52928 plus 79.102 power minus 3. So it's equal to 0.6038. Okay. So what you learn down, as I said, I'm not going to do the rest of the calculation. Is really straightforward. Calculating the first moment of area is the most difficult. So what you realize from this example, right? The most important thing is how you construct your shear flow helps you to dictate the what? Helps you to dictate the area. Yes or no? Or not? You get very, very confused. What is the area? What is the area, right? Okay. I'm going to do another example so that you can get more used to it. Okay. With the analysis also. Okay. The analysis is important. It's not just blindly doing examples. So I'm going to do one example, the next one. This one. Now it's slightly different. right? You can see like, oh, right. So before I make all these rules up, when I look at all this, it was not easy for me to solve. Then when I obey the rules, right,